We're making a video about the unit circle. Hi, it's me again, your instructor, Daniel Price. And what I'm going to do today is give you just part one of a series of videos on the unit circle. Now, right now, we have a lot going on. Some old hippie called another hippie tripping on apples. The definitions of the three basic trigonometric functions as they relate to a right triangle. But what we're doing right now is we're going to start putting those definitions to work inside of a circle on the Cartesian coordinate plane. Now the unit circle is called the unit circle because it has a radius of 1 unit. X squared plus y squared equals 1 is the equation of the unit circle. So most of you have already had an introduction to this in a previous math class, but regardless, what I'm going to try to do is put those two special right triangles onto a circle that only has a radius of 1 unit. Now behind me you see that there are three triangles, but what I did was I took the 30, 60, and of course the 90-degree triangle right here. And I don't need to put this right angle here if I don't want to, because if you have a triangle and two of the angles add up to equal 90, you know the third one's a right angle. So let's just get on with it. Watch this video several times because it's really, really important and understanding where those points come from on the unit circle. And in later videos, I'm going to show you how simple it is. But first, let's back up. If I gave you a point on the Cartesian coordinate plane, say the point 3, 4, you would have to use the Pythagorean theorem to find out what the radius is, which would obviously be 5. And then you could use the some old hippie called another hippie tripping on apples to find out what the sine of that angle is and the cosine and so forth. What we're going to do right now is I'm going to take that 45, 45, 90-degree triangle, which of course the side length's 1, 1, square root of 2. But what I want to do is shrink this triangle down. And I'm going to use this color. So what I want to do is make this triangle only this large. In other words, these two triangles are similar to each other by the angle-angle similarity postulate. Now, postulate's a statement that's accepted without proof, and in geometry, if two angles of one triangle are equal or congruent to two angles of another triangle, then those triangles are similar, meaning they have the same shape, but maybe a different size. And since our trigonometric functions are ratios, a comparison between two numbers, everything works out. The sine of an angle which is equal to 4 over 8 is the same angle whose sine is equal to 5 over 10 or 6 over 12, all equal to 1/2. So let's take a look at this. What we want to do is shrink this square root of 2, which is the length of this hypotenuse, down to just this. And this has got to be 1 because it is the unit circle. And the radius of the unit circle is 1 in any direction. So the question is, how do we shrink the square root of 2 down to only 1? Easy. You divide each side length by the square root of 2. So in other words, I'm going to divide this by the square root of 2. Square root of 2 divided by square root of 2 is 1. I'm going to divide this one by the square root of 2. And I'm going to divide this one by the square root of 2. And if I rationalize each of these, this becomes multiplying the top and bottom by the square root of 2. This side length right here becomes the square root of 2 over 2. This side length here becomes the square root of 2 over 2. And then the hypotenuse becomes just 1. So we're looking at just this triangle right now. This one kind of goes away into our memory. So what happens is this ordered pair that coincides with a 45-degree angle on the unit circle is the square root of 2 over 2 up the square root of 2 over 2. Why is that important? Well, if I wanted to find the sine of a 45-degree angle, all I need to do now is say, hey, the sine is the opposite length, which is this length right here, the y value, so the opposite over the hypotenuse. Well, since the hypotenuse is only 1, we don't even have to worry about it in this case. The sine of 45 is this y value, the square root of 2 over 2. So keep in mind, you've been doing this already. And a 45, 45, 90-degree right triangle, you have square root of 2, 1, 1. The sine of 45 is 1 over the square root of 2, so when you rationalize it, it becomes this. Either way you do it, you get the same answer. So this is awesome. This is really, really cool. So here's what I also tell some students. Who are you? CSI? There's no imaginary numbers in this class right now. So just remember, the cosine on the unit circle is the x value. The sine is the y value. Why? Well, once again, the sine is opposite. So this length right here is the height, the y value. If I wanted to find the cosine of 45, it'd be the square root of 2 over 2 over 1, which is simply the x value. And if I wanted to find the tangent, it would be opposite over adjacent. Square root of 2 over 2 over square root of 2 over 2 is equal to 1. Very cool. Which makes it even cooler when I want to come over here and talk about a 135-degree angle. So a 135-degree angle would be, this ordered pair is the same point here, it's just reflected over the y-axis. So that would make it negative square root of 2 over 2, square root of 2 over 2. And keep in mind, all students take calculus, the sine of a 135-degree angle, which has a reference angle of 45 degrees, is the square root of 2 over 2. The cosine would be negative square root of 2 over 2. Using the unit circle, not only do you have to not worry about rationalizing, you don't have to worry about the all students take calculus, because it's the x value in the second quadrant, which makes the cosine negative, which makes the tangent negative, and both of their reciprocal functions, but it keeps the sine and its reciprocal cosecant positive. That's a lot to take in, which is why this is like a good video. You stop it and rewind it and watch it again. You watch it again. You watch it again. You watch this video ever how many dang times it takes for you to understand this, if that's what your intent is. Now, if you just want to cheat and use Google and try to find answers to the questions and not understand this material, that's completely up to you, which is horrific, because you're at the time of your lives where you're trying to figure out what you're trying to want to be and what to do, and taking shortcuts in that process is never a good thing. So, let's look at this one. What we want to do here is shrink this triangle down so that we just have this right triangle. So in a 30, 60, 90-degree triangle, we want to shrink it down so that the hypotenuse is only 1, which is the radius of the unit circle. So I need to divide everything by 2. So when I divide this by 2, it becomes 1. When I divide 1 by 2, I get 1/2. And when I divide this by 2, I get that. So what happens is, let this triangle slowly disappear. So what happens with a 30-degree angle, we have the ordered pair, which is square root of 3 over 2. That's a 3, it's ugly. Over 2. And then up 1/2. So if I wanted to find the sine of a 30-degree angle, it's 1/2. It's on the unit circle. That's where that ordered pair comes from. These 16 ordered pairs that I'm going to show you on the unit circle, 12 of them come from our special right triangles. In other words, if I had a 30, 60, 90-degree triangle, this would be 1, 2, square root of 3. Sine is opposite over the hypotenuse. But on the unit circle, sine is simply the y value. So the definition of sine changes a little bit depending on what perspective you're looking at. So if you're looking at it from a triangle, yes, it's opposite over the hypotenuse. If you're looking at it on the unit circle, it is simply the y value. If you're looking at it on a circle that's not the unit circle, then it would be that y value over the r, the length of the hypotenuse. So notice we're being flexible with our definitions of sine depending on the context we're using. So, boom, there's that ordered pair right there. So here in this case, we want to take this triangle and shrink it down so that the hypotenuse is now 1. So if I divide everything by 2 once again, and just look at this little right triangle, this becomes 1/2 here, and this side becomes the square root of 3 over 2, and 2 divided by 2 is 1. So this ordered pair, which coincides with a 60-degree angle, is now 1/2 up square root of 3 over 2. That's where these points on the unit circle come from. They're just putting the special right triangles up there and then dividing by the hypotenuse so that we can make it all equal to 1. That's it. Holy cow. What's the sine of 60 degrees? Square root of 3 over 2. If I use this triangle, the sine of 60 degrees would be opposite over the hypotenuse, square root of 3 over 2. So on the unit circle, this last circle I've got right here, look how easy this is. So here's our 60 degree angle. So coming out to 60 degrees right there. Then we've got our 45 degree, and then we've got our 30 degree. And you're saying, how in the world can I remember? Oh, and we also have this ordered pair, which is going to help us out, and this ordered pair. So there's, holy cow, 5 ordered pairs right now. So what's going to happen? It's easy. It really is. It really is. Watch. 0, 1, 2, 3, 4. If you can count from 0 to 4, you've got most of your unit circle taken care of. Because what's going to happen is, now you're going to go 0, 1, 2, 3, 4. Take the square root of all them. The square root, the square root, the square root, the square root. I'm taking the square root, square root, square root, square root, and divide everything by 2. So divide by 2, 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 2, 2, 2, 2, divide by 2, divide by 2, divide by 2, divide by 2. And let me close the parentheses. And that's your unit circle. You're saying it don't look like it. The square root of 2, or square root of 0 divided by 2 is 0. Square root of 4 is 2, divided by 2 is 1. So that's that ordered pair right there, which we already knew that was 0, 1. So the sine of a 90 degree angle is 1. The cosine of a 90 degree angle is 0. Right here, that's our ordered pair that we saw right there. There's our ordered pair right there. There's our ordered pair right there. And the square root of 4 is 2. Divided by 2 is 1. And 0 divided by 2 is 0. Look at that. 1, 2, 3. And guess what? The other points on the unit circle are just reflections over the x and y axis. All these 3 ordered pairs reflect over here, which makes the y values stay the same. It's the x values that become negative. Because in this quadrant, x is negative, y is positive. If we reflected these points across this axis, or actually across the origin, then both the x and y values would be negative. And then if we just want to take these ordered pairs and reflect them down here, it is now the y values that become negative. I'm going to stop right here. This is a lot of good information. Please watch this video until you're sick of it. And that's more than once. Till next time. That's creating.